to be about identifying physical and chemical changes. In the AP content, we do have to identify if something is just a physical change or a chemical change. In a physical change, the things that have changed is going to be intermolecular attractions. So, for example, water molecules might lose their hydrogen bonding attraction, um, but it doesn't break the bond between the hydrogens and the oxygen in the H2O molecule. So a physical change can involve a change in that intermolecular attraction, but it doesn't change the composition. So the chemical formula is going to stay the same. Dissolution of a salt is actually a pretty complicated process. We'll talk a lot more about it when we get into thermochemistry. But for right now, when we dissolve a salt, so let's just imagine table salt because that's the one we're familiar with. When we dissolve a salt, such as sodium chloride, the Na and the Cl are going to separate, your cation and your anion. And that does break that ionic bond, but it's still considered a physical change because if we have dissolved the water, we can evaporate the water and the sodium chloride will remain unchanged and will be in crystalline form again. So there are some exceptions to that. A physical change doesn't break any bonds, but most of them it only breaks intermolecular forces. So my two pictures are an ice cube melting. That is just a physical change because it's H2O in the beginning and H2O in the end. And then butter melting is also going to be just a physical change. Now you have to be careful with cooking because the cooking process, sometimes we are just changing states of matter. And sometimes whenever we get more involved, like if I burnt the butter, anytime something is burned or browned, that's going to be more of a chemical change. So you have to be real careful reading into the questions. A change that involves breaking or forming chemical bonds is a chemical reaction. So chemical changes are going to be a chemical reaction. The composition of the substance does change, so I have a new compound at the end. And even though we are going through the process of conservation of mass, remember we've talked about that a few times with chemical bonding, in a chemical reaction, the total mass of your reactants will equal the total mass of your products. That's why we balance equations by putting coefficients in front of chemical formulas so that the total number of atoms on my reactant side is equal to the total number of atoms on my product side. But if we are making a new compound, the mass of the new compound will not be the same as the mass of the original reactants. So sometimes change in mass is evidence of a chemical change. We're not saying that we've created or destroyed mass. We're just saying that it's a new compound because it has a different mass. Just like every element on the periodic table has a unique mass, every compound has a unique mass. When we decide if there is a chemical reaction, then there has to be some sort of evidence. So my two pictures, I have a nail, it turns rusty. There was a color change. That was my evidence. There would also be a change in mass because when a nail becomes rusty, it is oxidizing and forming an oxide compound. So it's bonding with oxygen. So on the left, that nail is just iron. On the right, it's going to be an iron oxide. Those will have different masses. With cooking, my left picture is dough. My right picture is bread that has been baked. Again, with cooking, that process, when there is a color change, that is often going to be a chemical reaction that's happening. So let's read through a few AP style questions. So it says, which of the following describes the changes in forces of attraction that occur as H2O changes phase from a liquid to a vapor? So let's pause for just a second and let's talk about chemical bonds versus intermolecular forces or attractions. So there are actually three chemical bonds. The chemical bonds are going to be, we have ionic, which involves transfer of electrons. It's going to have your positive and negative thing. We have covalent, which is going to share at least an electron pair. And then we have metallic, which is weird, and we say it has a sea of electrons. All of these are considered to be chemical bonds. Okay. In a physical change, those are not going to break. There's also a lot of things called intermolecular forces. You're going to talk about those much more in depth as the year goes along. And an intermolecular force is just an attraction between molecules. So it's an attraction from one molecule to a different molecule. This says, which of the following describes the changes in force of attraction that occur as H2O changes from a liquid to a vapor? So we know that changing from liquid to vapor is only going to be physical, because liquid is H2O, vapor is H2O. We can't break bonds if it's physical. So that cannot be true because we cannot break chemical bonds. Okay. You have to be careful because this says hydrogen bonds. If you have not talked about intermolecular forces, yes, hydrogen bond is actually not a chemical bond. It's a misname. A hydrogen bond is what we call a force of attraction. Okay. Covalent bonds are chemical bonds. Not gonna break because in physical bonds, chemical bonds don't break. Ionic bond, not gonna break because physical bonds, chemical bonds don't break. Covalent bond, again, not gonna happen because chemical bonds do not break. So the answer for this one is going to be letter B, hydrogen bonds between H2O molecules are broken. Even if you don't know intermolecular forces, you still can problem solve because you should know the three basic types of chemical bonds. This next question says a student places a sample of a pure metal in a crucible and heats it strongly in air. Data from the experiment are given in the table above. The final mass was determined after the sample was cooled to room temperature. Which of the following statements related to the experiment is correct? So let's look at our data table first. So up here, the empty crucible is just 12 grams. When we put our sample in, before we heated it, it was 14.4 grams. After we heated it, it's 16.0 grams. So our options are the mass of the sample decreased, so a physical change occurred, or the mass of the sample increased, so a chemical change occurred when bonds formed between the metal and another substance. So we can see that from here to here, the mass increased, and so it is going to be the mass increased, not the mass decreased. And it is a chemical change because in order for the mass to change, that means it made a new compound. This is like my example with iron a minute ago. If we heat certain metals in air, they form a metal oxide. And when they bond with that oxygen, it is going to increase their mass. And then our last one for today is a student mixes 20 grams of white potassium chloride crystals with distilled water in a beaker. After the mixture was stirred, no crystals are visible and the solution is clear. After several days, all the water evaporates and white crystals are found in the beaker. Which of the following pieces of experimental evidence would best help the student to confirm the new compound has not been made and it was only a physical change? Okay, so we're trying to prove that there is only a physical change. A solution does not change color after stirring. Well, if it changed color, that's typically a chemical change evidence, so that's not going to be true. The KCl crystals were no longer visible after mixing water. That is true, but that's what happens when you dissolve salts. If I take salt, table salt, sodium chloride, and dissolve it in water, they quote-unquote disappear. But them being visible or not visible has nothing to do with being chemical or physical. That just means that a salt is dissolving, so that's not a realistic explanation. There's a temperature change in the solution during the dissolving process. Well, that's actually chemical. In chemical reactions, there's often bond breaking and bond forming, and so they're endothermic or exothermic, and they will change temperatures, how we measure that, so that is not true. And the last one, after the water has evaporated, the white crystals in the beaker have a mass of 20 grams. Well, what we started with had 20 grams. So if what we end with had 20 grams, then that means it's the exact same compound, because remember, we've talked about how all elements and all compounds have unique masses. And so this one is going to be the correct answer. So just be careful with AP Chem questions about chemical and physical changes. You've got to look to see what the evidence is, and you really have to think through the problem about what the problem is asking. Make sure that you're answering what the question is asking.